Hello, everyone. My name is Wang, and today I'm talking about a cold plasma-based technology for hydroponics with basil growth, which can be produced both on location and on demand. But what is plasma? Well, plasma is the fourth state of matter, and we have seen it before in the Northern Lights and in lightning. You see it when you have a gas and you add enough energy to it, it transitions into the plasma phase, where it can produce nitrates, an important component of commercial fertilizers. However, in contrast to commercial fertilizers, plasma can be produced in a cold atmospheric pressure environment. So if we take our plasma source and we treat a liquid, we can produce nitrates in that liquid and use it to grow plants. That is particularly important also because of the hydroponic industry. Here's an example of a hydroponic setup. You can see from this picture that there is no soil. Well, the reason is that in hydroponics, a recirculated nutrient solution provides nutrients for plant growth. However, if the nutrient solution becomes contaminated by foodborne or plant-borne pathogens and microorganisms, this can jeopardize the whole system and lead to hydroponic crop loss. Maybe we can suggest the use of plasma in this case. We know from the literature that plasma can inactivate microorganisms and help with plant growth, but we saw a gap in terms of what happens to the quality of the plants. Well, that's what we did. Our objectives were to look at the plant growth, disinfection, and plant quality of hydroponics with basil plants grown with our plasma-activated nutrient solution in comparison to a conventional hydroponics with basil plant. Our results showed that we use a similar amount of water and energy and space as a conventional hydroponic. But when we look at plant growth, our plants were actually more attractive. Why? Because they were taller and they had more leaves. This is interesting because conventional disinfection methods for the hydroponic industry can harm plant growth. But in our case, we actually improved it. Also, when we look at the growth environment, we saw that there was a reduction in the amount of microorganisms grown in the nutrient solution for our plasma one compared to control. We had less algae, and we also had a complete inactivation of E. coli DH5 alpha. This led us to conclude that plasma technologies are a promising alternative for hydroponic sweet basil farmers, such that they can make safe, high quality, and high yield products. Thank you. I would also like to thank people at Rutgers University and Drexel University, as well as the USDA NIFA, without whom this study could not have happened.